All right, let's talk a little bit about these two absolute value inequalities to talk about why we deal with these absolute value inequalities the way that we do. In this first one on the left, we're looking for numbers that the absolute value of them is less than 5. So just thinking about numbers that would satisfy this. So these would be numbers like 1, 2, and 3, because the absolute value of those are less than 5, but also numbers like -1, -2, and -3 also work. Because when we take the absolute value of these, we still get a value less than 5. Numbers that wouldn't work in this case would be numbers that have large absolute values. So numbers like 6, 7, and 10, but also the negative values of those, like -6, -7, and -10. Because when we take the absolute value of these, they'll end up being greater than 5, so these ones in red don't work. Okay, conversely, let's talk about this other situation right here. Looking for numbers that work for x in this case. In this case, we're looking for numbers that have an absolute value greater than 5. So numbers like 6 and 7 work, but also numbers like -6 and -7, or -10 for that instance. So when we take the absolute value of those numbers, we get the positive version of them. Numbers that don't work in this second case are numbers like 1 and -1, 2, -3. Numbers that when we take the absolute value, we get a value, absolute value that's less than 5. So only the numbers in the second one have absolute values greater than 5 work. So there's a large negative m, large positive numbers. In the first case over here on this side, we only get numbers that are small, that are really close to 0. So the idea is, on the left-hand side, when we have the absolute value is less than a number, we get these small numbers, kind of condensed around 0. When we have the second situation, we have an absolute value is greater than a number, we get these large numbers that we're looking for. Let's look at a visual representation of this and talk about the interval notation solutions to these sets. Okay, so first on this left-hand side, again, we're looking for numbers that are closer than 5 units from 0. So if we were to color in the number line for this, we're looking for these numbers between -5 and 5. In this case right here. So we've got kind of these numbers huddled around 0. This is when he says the less than situation that we're dealing with here first. If we're going to create the interval notation of this, we have one simple interval from -5 to 5, and since there's no equal sign there, we have these parentheses in this case. In this second situation right here, we're looking for numbers, large numbers, or numbers that are further than 5 units from 0. So if we were to color in the number line, these will be numbers outside of 5 in this case, and -5. And again, these are the numbers that have an absolute value that are greater than 5. If we were to write this set in interval notation, what we get is from -infinity to -5, and the set from 5 to infinity. And again, the reasoning we have on the left, we have this one condensed set, is because we're looking at an absolute value that was less than. On the right-hand side, we have this numbers that are away from 5 or further than 5 from 0. And so we have these two separate, we call them disjoint sets. In general, what this means is that when we're dealing with a problem that has an expression that's less than a value, we get this nice, neat one interval that we're talking about, numbers centered around 0. When we have an absolute value inequality expression, or inequality that is greater than a value, we get these two separate sets that are kind of exploding out towards infinity and -infinity. And that's, in each of these cases, will create different solutions for the different kind of problems that they are.